In this video, I'll be showing you how to use the 8x8 matrix with Arduino. I'm going to show you how to connect it up to the Arduino, and I'm going to show you the code it takes to be able to get the Arduino to put images on this 8x8 matrix. So without further ado, let's get started.
Okay, so now here is the 8x8 matrix right here, and something I want to quickly explain is how these pins are laid out, because you may not know which pins to connect to the Arduino. So basically right here you see this text. This is the front part of the 8x8 matrix. So these pins are the first pins of the 8x8 matrix. Now the pin on the far left side is pin 1 on the 8x8 matrix, and then we go on to pin 2, pin 3, pin 4, and all the way up to pin 8, which is all the way on the other side, on the far right side of the text. Now we're going to continue counting up to 9. We have to come to this other side. Now which pin is pin 9 over here? It's not this one right here, it's this one. So basically this is pin 8, and then we go skip right across to the opposite pin on the other side, and this is pin 9, pin 10, pin 11, pin 12, and we go on to all the way up here to pin 16. So basically that's just something I want to tell you. So now let's go ahead and look at the circuit to connect this up to the Arduino.
Okay, so now here is the 8x8 matrix, and this is how we connect it up to the Arduino. And so as I said, right here, this is where the text would be right here of the model number, and the pin on the far left of this model number will be pin 1. So basically what we do is we go ahead and we connect the row pins first to the Arduino. These are all the row pins, as you can see. The row pins are responsible to provide positive power to the LEDs, so they are connected to all the anode sides of the LEDs. And the column pins are responsible to provide negative power to the LEDs, which are then connected to the cathodes, basically. So basically what we have here is we're going to go ahead and connect row 1 right here, which is pin 9 right here. And you have to understand that these pins are kind of mixed up, so they're really mixed. So you have to look at like a chart like this right here to know which pins are which on the 8x8 matrix. But in this case, if you just follow this, everything should be laid out properly. So right here, this is row 1, which is pin 9 on the 8x8 matrix, and it's going to be connected to pin 13 on the Arduino. And then we have row 2, which is connected to pin 12, and that in row 2 on the 8x8 matrix is pin 14 on the 8x8 matrix, and so on with all these other connections. And then we also have the column pins. For example, column 1 right here, which is connected to pin 5, it's going to be connected to pin 13 on the 8x8 matrix. And of course this column pin will have a 330 ohm resistor. For me, I actually suggest you have a little bit of low resistance, maybe 220 ohms, because these resistors aren't just providing power for one LED, they're providing power to a whole column of LEDs. And each column has 8 LEDs in them. Okay, so then we go on with all the other column pins. Once we get to column 4, we have no more digital pins to use, so we have to start using the analog pins. So what we do here is we just connect column 5. So we start here, column 5, column 6, column 7, and column 8. So we continue counting this direction from starting at A0 and going to A3. So we just switch over to the analog pins after we run out of digital pins, and we continue connecting the circuit up. So go ahead and connect the circuit up, and then I'll also connect the circuit up as well. Okay, so let's do that now. Okay. Okay, so now here is the code, and as you can see right here, we have some constants. These are for all the pins, and so the first thing we have is we have the array row pins. This array will be holding all the pins that we have connected the row pins to on the 8x8 matrix, which is pin 13, which is row 1, pin 12, which is row 2, and pin 11, which is row 3, and so on. We have it in order from 1 to 8 right here. And then we also have the array call pins. This is going to be holding all the column pins right here. And they're also all in order from 1, which is digital pin 5, to A4, which is column 8 on the 8x8 matrix. And so next we have some arrays. These are basically images on how the LEDs will be turned on and off to make an image, basically. So this image is supposed to be a smiley face. I don't know if you see it, but the ones, they are all shaped like a smiley face because the ones represent the LEDs that are going to be on. The zeros represents the LEDs that are going to be off. And as you see, of course, we have a bigger array than like these. This array is 8 segments long, but also they have arrays within these 8 segments that are also 8 segments long. And that's how we get this box right here, which is the exact size or the exact pixels of the 8x8 matrix. And so basically we have other images. We have the up arrow. You can kind of see this if I mark this right here. You can kind of see the up arrow shaped out of like ones. So also we have the halt, which is the one I'm going to use. And how we tell the code which image we want is we just call this name right here of the array, and it will go ahead and do that for us. And so then we go into the void setup. I just set up all the pins the crappy way. So then we go into the void loop. What we do with this 8x8 matrix is we just go to column by column by column and turn each column low, because by default every column is high, to make sure that the LEDs, even if the rows are given positive power, that means each LED is getting positive power on both sides, which means they won't turn on. But if a column pin is turned low, all those LEDs on that column are going to be able to work if they are being provided positive power, because of course the column pins are connected to the cathode sides of the LEDs. So basically that's what we do. We just go by column and turn each one low one at a time. And so this makes it so that one at a time we turn each column low, and we see if if any of these LEDs within this column need to be turned on. So we go one by one through all these LEDs and turn all the ones that need to be turned on very quickly, and then we go to the next column, turn them all, and turn all the LEDs that need to be on in that column, and so on, very, very quickly, so that eyes can see that each LED is turned on one at a time. So basically that's what we do here, is we just go through a full loop right here, and we set up a variable called call. This is set by default to 0, and then we go ahead and we're going to continue looping this full loop until call is no longer less than 8. And we're going to go ahead and every single time we loop this full loop, we will increment call. Now what's going to happen here is every single time we loop the full loop, column is going to be incremented, as I said right here. And that means we go to the next column and then turn that column low, which we do inside this full loop right here. We say call pins, then which is the array, and we just the current number that we are at of call, we turn low. And then within this, while this column is being turned low, we will do this full loop right here, and we are set the row variable. This is for all the rows. So while the column is being turned low, we're going to go through and iterate through this list of row pins right here, which means we turn on these LEDs one by one within this column. So that's what we do here. We just say we continue incrementing this full loop until row is no longer less than 8, and we're going to increment this a row every single time we loop this full loop. And we just do digital write. We write to a digital pin, and in this case it is row pin, and we specify the row that we're at. And then when we go into the matrix that we're using, which is the image that we want, and this would be the halt image right here. This is how you call it. So in this case, if you want the up arrow, you would say up arrow here to call this array right here, which is the image of the up arrow. But in this case, as I said, I'm just using the halt. And so basically all we say is we just give it the row and the column of this LED that we are checking if it should be on or off. And so that's what we do, and just go through every single one by one very quickly and turn them on or off. And we just delay 2 milliseconds because of course these LEDs need to be on for a little bit because they need to light up and our eyes need to be able to have time to see it, and then quickly turn everything back off. Okay, so we just go ahead and quickly do that. We just turn column pin to high, which means we turn all the LEDs off in the columns. And then we just go ahead and continue doing this. We go column by column and continue doing this over and over again so quickly. And so basically that is how the code works. And so now we can go ahead and see our project in action. Okay,
so now you can see that there is a halt right here on the 8x8 matrix, but you can see that it's not fully complete. It's having this type of effect. Now, for me, all the LEDs are on. I see them all on, but since they're turning on and off very quickly, the camera actually sees some type of effect that the Arduino is doing with the 8x8 matrix, and I don't see it that much. Now, what I'm going to do is I'm going to turn off the light, and it's actually going to look a bit different. Now, as you can see, it's actually fully brightened up. You can still see a little bit of movement with the halt, but I can't see it at all, but the camera still can see a little bit, which is a kind of a cool effect actually. But anyways, so basically that is the project. So if you like this video, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing if you want to see more content like this. Thank you everyone, have a great day.